processes. Last time we see about near about three machining different machining processes. Now we start with the fourth machining processes is called as the electro discharge machining processes. What are the classification of the non-traditional machining processes? Here is the electro discharge machining processes. This comes under the third classification called as electrothermal processes. Here, last time we see about the classification based on the energy levels. This is the third energy level called as electrothermal. Electrical and thermal energy are used to remove the metals from the surface. Is called as machining by the electro discharge machining processes. In this third group containing these four types of processes, is one is called as electro discharge machining, second is called laser jet machining, third is the plasma arc machining, and fourth is the electron beam machining processes. Okay, now start with the electro discharge machining processes. What is the electro discharge machining processes? Electro discharge machining is an electrothermal non-traditional machining process where the electrical energy is used to generate electrical spark. Here is the important thing: we can generate the electrical sparks, the spark having the lot of energy, thermal energy. And this thermal energy are used to remove the material. It is called as due to the thermal energy of the sparks. Also is called as the spark erosion methods or spark erosion processes. Here again, we remove the material in the form of the erosion of the workpiece material. This erosion due to the spark, not in the form of the chips. We can remove the materials in the form of erosion levels. We can melt and vaporize the materials of the workpiece. EDM is a thermal erosion process whereby material is melted and vaporized. Is the major methodology for these spark erosion methods. First, metal is melted and then vaporized. So, in this process, there is no chance of the material in the form of bursts or microparticles because they are melted and vaporized it. Okay, so it is the very important machine commonly used in industry, the electro discharge machine for the tool room as well as the design purpose processor to manufacture the dies and the special component of the machine. Okay. Work material to be machined by EDM has to be electrical conductor is the primary requirement of this electro discharge machining process. Now let's see about the what are its working principle of the EDM processes. Generally, is the process covers the third types of electrical domain sources called as electro discharge or electric energy are used to remove the materials. So heat is generated by the spark used to remove the material from workpiece. Generally is the spark erosion processes. Second part for the workpiece working principle of the EDM, you should maintain the gap. This gap is called as a spark gap. When this spark gap is having 0.01 to 0.5 mm. Tool and workpiece is immersed in the dielectric fluids. Here the second concept called as the dielectric fluid. Last process we see, and in ECM process we discuss about some electrolytes. These electrolytes are used for conducting these electric current between these electrode and cathodes. Here we use the dielectric fluids between these electrode and workpiece and tool and workpiece. Okay, high temperature is generated near about 10,000 degrees temperature is generated in this process. Here the first figure shows the general principle of the electro discharge machining processes. Tool is generally called as cathode, workpiece generally formed as anode, and this gap between these two workpiece and tool filled by the dielectric fluid. Okay, later we discuss about that what is meant by dielectric fluid and what are the importance of the dielectric fluids. So this spark is formed between these two formed between this gap filled by the dielectric fluid. So this tool to work is called as the spark gap. Now second figure shows the actual how the plasma is formed. This plasma is formed. In this plasma generated a spark. This spark having very high temperatures. So this high temperature first melted the particles on the workpiece, and this particle first melted and then gets evaporated. The spark is struck between this tools and tool to workpiece. So workpiece created the spark created on the workpiece is a craters. This crater to remove the materials. Now these electrodielectric fluids are used to remove the all the solidified metals or any melted parts between these workpiece and gaps. Okay, so in this process but heat affected zone is generated due to the high temperature of the spark. Last three processes there is no heat generated in abrasive process and in ECM process, but in this process we generate the heat affected zones. So this process is limited only for the conductive materials, but it is very important to form to use for the very high hardness or brittle materials, but materials should be conductive one. These are the primary requirements. Okay, now come to the what are the setup of the EDM processes. Which types of setup? A setup concept of the four major components. Okay, tool and work is a primary requirement, a primary process requirements. Then directory feed system is one of the important thing. Then again one of the important thing, RC circuit, power supply units, and third is tool feed mechanism. The inputs or setup of the EDM process. The figure shows the all the components. This workpiece is here, tool is here, tool is upward direction towards the workpiece. That workpiece is dipped in a dielectric fluid, completely immersed in a dielectric fluid this in the tank, and the workpiece is called as anode, tool is called as cathodes. In this there is servo mechanisms are used for the constant tool feed mechanisms by the servo mechanisms. Now here is a current control system and rectifier are used to generate a spark between this workpiece and tools. These are the general setup of the. Okay, we not go deeply go for the setup of the EDM process, but 4 points of these setups are very important. Tool and workpiece, dielectric fluid systems, RC circuit is called as resistance capacitor circuits, and power supply units. Tool feed mechanisms are the important components of the EDM setups. Then comes to the EDM tools. This is the prime requirement of the EDM tools material is it should be electrical conductor, the primary requirements. Then it should have good machinability, thus allowing to easy to manufacture of complex shapes. It should have low erosion rates or good work to tool wear ratios. It should have low electrical resistance. It should have high melting points. The tool is having very high melting because the temperature between tool and workpiece is near about the 10,000 degrees Celsius. So the tool is soft, highly conductive, but having very high melting points. Okay, now it should have high electron emissions. The tool material is copper, brass, alloy, zinc, and hardened plain carbon steels, copper, tungsten, and silver, tungsten carbide, copper graphites, and graphites. These are the tools. Then EDM tool wear ratio. One major drawback of EDM is wear that occurs on the electrode at each pass. Tool wear is given in terms of the wear ratio, which is defined as a tool wear ratio is called as volume of the metal removed from work divided by volume of the metal removed from the tools. Here is the tool wear occurs on workpiece as well as tool also, because this spark when they struck the spark from the tool to workpiece, at that time the sparks energy, heat energy remove this small amount of material from tool also. So tool wear ratio is one of the important things. Tool wear ratio of the brass electrode is 1:1. For most other metallic electrodes. It is about 3:1 to 4:1 with graphite with the highest melting point near about 3500 degrees Celsius. The tool wear ratio may range from 5:1 up to 50:1. So this is about the tool wear for the electrodes. Then EDM dielectric fluid. Now come to the major role of the fluids between workpiece and tool called as a dielectric fluids. What are the functions of the dielectric fluids? Okay, these are the common fluid which can carry the currents from these, or this can carry the power supply from tool to workpiece. It should be act as an insulator until required breakdowns voltage is attained. First it should be insulator, then it should be act as a conductor. Okay, I explained when we go for the working principle of the EDM processes. Okay, then it should be act as a conductor when breakdown voltage is reached. Clean the spark gap is called as flushing between the tool and workpiece. Primary requirement for the any fluid or direct applied fluids. Cool the workpiece. Important, this act as a coolant for the tool and spark agents. Okay, it should be act as an insulator until breakdown voltage is attained. When we start this supply goes to the tool. That in between there is a small circuit called as the RC circuit. When we attain the volt breakdown voltage, up to this breakdown voltage it should be act as an insulator. They not carry current or not carry the supply from tool to workpiece. And after we can attain these capacitors supply, then it can act as a conductors. Okay, so what are the characteristics of the dielectric fluid? Is the having the low viscosity, having high flash point, chemically neutrals, and high dielectric strength. The strength is very high because this act as an insulator and the act as a conductor when breakdown voltage is reached. Okay, what is the different types of dielectric fluids? These are hydrocarbon oils, distilled water, then kerosene, paraffin oil, transformer oil are the common dielectric fluids. Most of the kerosene are used in industry as a dielectric fluids. Okay, now come to the EDM RC circuit. Function of the spark generator. The RC circuit used to generate the spark. Last time we told about these variable resistance and sparks for the tool and workpiece gaps. Okay, when the supply is on, at the time we adjust this variable resistance to charge these capacitors. These capacitors having charging capacity to break down this gap between the tool and workpiece. When we attain this charging, after this charging is completed, this can directly discharge between the tools to the workpiece. So this charge make a spark between this tool and workpiece. Okay, these are the characteristic diagram for this charging and discharging. Here is called as a charging for the voltage is applied to charge the capacitors at a certain time with very low discharge times. They can suddenly discharge. Then again second cycle starts. Now next cycle. This called as every cycle generate a single sparks. Okay, then what are the functions? That was to adequate voltage to initiate and maintain the discharge, to adjust the discharge current intensity, to adjust the discharge durations, and to control the recurring rhythms of the discharge. Called as cycles. The one cycle produces one sparks. So for a millisecond, the circuit produces thousands of these sparks between these workpiece and tools. They can generate a thousands of these cycles. In that cycle, the charging time is very high, more than the discharging times. This charging time more, so we can charge the capacitors for the discharging levels. Okay. So we can first how to discharge due to the insulator acting directly act as a insulator. When the charge completed, this dielectric fluid between the workpiece and tool act as a conductors. They can conductors means they can carry these sparks from tool to workpiece. Now, EDM process parameter. Again, this process having parameters. First is called as supply voltage, breakdown voltage, then resistance and capacitance, spark gap, and pulse generation, pulse durations, and spark frequency. There are the six input parameters. This parameter changes the outputs. Supply voltage, breakdown voltage. Where breakdown voltage increases, it increases the spark energy. Then resistance and capacitors increases the capacitance, resulting in increase the motor terminal rate. Decrease the resistance, resulting in increase the motor terminal rate. Spark gap, decrease the spark gap, lower the motor terminal rate. So it means you can maintain the spark gap. Pulse duration, decrease the pulse duration, will result in high tool wear and increase the result of lower the MRR and spark frequency. What are the advantages for these processes? First is the advantage called hardness, toughness, and brittleness of the material possesses no problems. No problem for the hardness, toughness, and brittleness. Due to this, EDM can be used for machining the materials that are too hard, brittle to the machine by the conventional machining methods. The method does not leave any chips or burrs on the workpiece material. These are the spark welding method in which you can melt and vaporize the materials. Okay, cutting forces are virtually zero cutting forces, so very delicate and fine work can be done. The process dimensions, repeatability, and surface finish obtained in finishing are extremely good. Because of the force between the tools and the workpiece virtually zero, very delicate work can be done. These are the common advantages. Then, of course, having some disadvantages. This process requires only electrically conductive materials. Without electric conductivity, it is not possible to generate the sparks. Electrode wear and overcut of the serious problems. Here is wearing of the tool wear also due to the spark. Reharden high stress zone is produced due to the striking of the sparks on the workpiece surface. Preferably square corner cannot be made by these processes. High specific energy consumptions of the process and low material removal rate. These are the general disadvantages of the processes. What are the applications? Applications are machining the material that are electrically conductive. EDM is widely used for machining burr-free intricate shapes, narrow slots, and blind cavities. For example, dies and molding dies for moldings, dies for casting, plastic molding, wire drawings, cold heating, forgings, extrusions, and press tool dies are generally produced by the EDM processes. EDM methods: small holes about 0.13 mm, 0.13 mm diameters, easily generated, and partially useful for machining of small holes, orifice, and slots in diesel fuel injection nozzle or in aircraft engines, air brakes, valves, and so on. These are the general advantages applications of the processes. Thank you.